9.1 Linear, piecewise, and step functions. A graph that represents the amount of water in her bathtub is shown. Time is measured on the x-axis, and the amount of water is measured on the y-axis. Number 1. Is this relation a function? Yes. A function is when there is only one x value for every y value. So if we look at the picture over here on the right, it's always changing. All of the x values are different for all of the y values. So yes, this is a function. Number 2, describe each of the 3 intervals in context. Well, the first interval is right here in red. And as we can see, the amount of water in the bathtub is increasing over time. So for the first interval, water increases over time. Okay, for the second interval, you should notice that the water in the bathtub is staying the same. So water stays the same over time. And the third piece, you will notice that the tub is emptying, and so the amount of water is going down over time. So we would say water decreases. Maybe if I can spell. Over time. Okay, number 3. Did the bathtub fill or drain faster? How do you know? Well, by looking at the chart over here on the right, we can see that it took less time for the tub to fill, and it took more time for the tub to drain. So did the bathtub fill or drain faster? It filled faster. And it says, how do you know? I'm going to say steeper slope. Okay. Now, moving on to example 2. Emily won $48 in a ping pong tournament. For the first days after her victory, she spent $3 each day. That sounds important. I'm going to highlight that. Then, she spent nothing for the next 5 days. After those 5 days, she spent $1.50 a day until her prize winnings were gone. So, you've got this table. It says, complete the table to show the amount of money Emily had remaining after each day. So, in the first column, it says time since the tournament in days. And the second column says the prize money remaining in dollars, so how much money she has left. Well, we know that on day 0, that was still the day of her tournament. So we know that on day 0, she still has $48. That's my best 48. Okay, now on day 1, it says for the first 5 days after her victory, she spent $3 each day. So what I'm going to do is draw a line. 1, 2, 3, 4 for the first 5 days. This is kind of our cutoff. For these first 5 days, she spent $3. So we're starting with $48, and if we spend $3, that means we're losing $3. So 48 minus 3 would give us 45. And then 45 minus 3 would give us 42. And then 39. And then 36. And then 33. So you can see on each day how much money she has. Okay, back at the top it says, then she spent nothing for the next 5 days. So day 6, 7, 8, 9, and 10, she spent nothing. So I'm drawing a line to separate that section. Okay, if she spent nothing, that means that she should still have $33. So day 6, 7, 8, 9, and 10 should still all say $33. And then after those 5 days, she spent $1.50 a day until her prize winnings were gone. So if she spent $1.50, we're subtracting $1.50 every time. That means on day 11, she would have $31.50. On day 12, she would have $30. On day 13, she would have $28.50. And on day 14, she would have $27. So what we're going to do now is come over to this graph. At the bottom of your page, it says plot the points on a graph. Make sure you label your axes with the appropriate units. We're going to make our first column represent the x-axis and the second column represent the y-axis. Okay, so our first column is days. So x-axis is days. And your y-axis is the prize money. So I'm just going to put the $sign for money. And now we need to plot these points. So if we plot these points now, our first one is 0.48. Okay, I'm going to zoom in a little bit so I can get a better graph, hopefully. Okay, so 0.48, so over 0 up to 48. Then over 1 up 45. Over 2 up 42. Over 3 up 39. Over 4 up 36. Over 5 up 33. Now you guys, you should have a lot better points that create a line. Mine aren't looking very great. Okay, but you should be able to connect these points and draw a straight line, hopefully. I'm going to try my best here. That's my best straight line. Now for the second section, you have 633, 733, 833, 933, and 1033. You'll notice that those should all draw a line. And then for your third section, you've got 11 and then 3150, 1230, 13 is 2850, 14 is 27, and that's all of our points. Okay, essentially, if she was to keep going, our points would continue to go down, losing $1.50 per day. Okay, what I want you to do is draw your best line and see where it comes to on the x-axis. Again, I'm hoping yours is better than mine. So that's the line that I came up with. And if you look at this very bottom point right here, this should be where she runs out of money. So I'm guessing at about day 32-ish, she's going to run out of money if she keeps spending $1.50 a day. Okay? Now, on part C at the bottom of the page, it says, determine when Emily will spend all of her prize money. Well, we just estimated on our graph, and we said, hey, we think it's going to be about 32 days-ish. Okay, your graph might look a little bit different. But we're going to do this algebraically and see if we get the same thing. Okay, so we're going to come up with an equation. We know that she has $33 and she's going to be spending $1.50 a day. So we're going to say 33 minus $1.50 per day, so D. And we want that to equal 0. We want to know, when will she run out of money? Well, let's solve for D. Minus 33 on both sides. Okay, your 33 should cancel. And you're left with negative $1.50D equals negative 33. And then divide both sides by negative $1.50. Okay, your negative 150 should cancel. And then D equals, negative divided by negative turns to a positive. And negative 33 divided by negative $1.50 is 22. So we found that it would take 22 days for her to run out of money. Okay, but remember, we started at day 10. Because we said, okay, at day 10 she has $33. So there were already 10 days previous to that. So what you're going to do is take your $22 and you've got to add 10 more days to that. That will give you a total of 32 days, which actually was our estimate from our graph. Okay? All right, go ahead and flip your page. It says, the graph that you created represents a linear piecewise function. Recall that the linear piecewise function is a function that can be represented by more than one function, each of which corresponds to a part of the domain. Okay, it says, what is the domain of this problem? Well, domain is the x values. So if we think back about our graph, our smallest x value and our biggest x value, well, our x value was days. The least amount of days that we had was 0. And we know that she would run out of her prize money at day 32. So our domain is from 0 to 32. And we are going to use brackets to show that the 0 and the 32 are included within that domain. Then it says how many pieces make up this function. Well, look back at your picture on the page before. I can't flip my page in here, so you're going to have to go back. Okay, you should see that there are 3 pieces. You've got a decreasing piece, a flat piece, and a decreasing piece. So that would be 3 pieces. Then it says, what is the domain of each piece? Okay, looking at your table on the previous page, you're going to go through the x value column. Okay, our first section went from 0 days to 5 days. So that domain would be from 0 to 5. Okay, 0 and 5 are both included in that first section. Now your second section always has to start off with what your previous section left off with. So that means that our next section has to start off with 5. And if you look at the table on the other page, you know that the second section ends at day 10. Now, day 5 was included in the first piece, so we have to use parentheses to show that it is not included in the second piece. But 10 is included in the second piece, so we use a bracket. And finally, our third piece. Our third piece has to begin with 10 because that's what we left off with. And it looks like it goes all the way to 32, to when she ran out of money. Because 10 was included in the second piece, we must use a parenthesis to show that it's not included in the third. And 32 is included in our last and final piece. This is how you are used to writing domains. Okay, now I'm going to teach you a new way to write the domain, which is the way that you will use for this chapter. So what you're going to do, you're going to put your x right in the middle. That's your variable. Your first piece is in between 0 and 5. So you put x right in the middle of 0 and 5. Your symbols in between are always going to be the less than symbols. So less than, less than. Then you have to double check. If it's a bracket, you need to put less than or equal to. So in this case, 0 is a bracket, so we have less than or equal to. 5 has a bracket, so we put less than or equal to. Okay, so these mean the exact same thing, just written in different forms. If we read this, we start from the inside out. X is greater than or equal to 0, and x is less than or equal to 5. So what it's saying is somewhere between 0 and 5. Okay, now look at the second piece. On the second piece it says 5, 10. So I have 5, x in the middle, 10. Because 5 has a parenthesis, we use the less than sign. But because 10 has a bracket, we use the less than or equal to sign. Okay, that one's done. And your third one should go 10. X is in the middle of 10 and 32. 10 has a parenthesis, so we say less than. 32 has a bracket, so we say less than or equal to. And that is your domain of the picture that we have on the previous page about the prize money. Now, it wants us to determine the equation that represents each piece of the function for each given time period. So off to the side, I'm going to give you some steps. Okay, your first step, step number 1, is going to be find slope. Okay, remember slope is m. Okay, and your slope is going to be the rise over the run. You've heard that before. Your second step is going to be plug into point slope. Okay, you've done point slope before. It looks like this. Y minus y1 equals m, parentheses x minus x1. So you're plugging into that formula. And your third and final step is to put it in the form y equals mx plus b. So these are your 3 steps. So what we're going to do, first step is to find the slope. So from 0 to 5 days, our slope is the rise over the run. Okay, to find the rise over the run, you're going to tell how your y values are changing over how your x values are changing. So if I look back at the table on the previous page, from 0 to 5 days, my y values are going down 3 every time. So that means that my m would be -3 over, and then I look for the change in all of my x values. They're going up by 1. So that means my slope from 0 to 5 days is -3 over 1, or -3. Okay, now go from 5 to 10 days. Your y values are not changing. They are staying the same every single time. So there is no change, 0, over the x's are changing by 1. Okay, remember 0 divided by 1 is just 0. So the slope in the second piece is 0. Your third piece, the change in your y values is negative $1.50. It's going down $1.50 every day. And on the bottom, your change in x's, it's going up 1 every time. So your slope is negative 150. Okay, that is step 1. We found all of the slopes for each piece. Now, step number 2, we are going to plug into point slope formula. Okay, point slope formula, y minus y1 equals m parentheses x minus x1. You may pick any point within the section. I like to just pick the very first point. So if I pick the very first point, it would be 0, 48. I'm looking at the table on the previous page. So that would give me y minus, well, my y1 would be 48, equals my m, which is -3, parentheses x minus 0, because 0 is my x1. Then I distribute, right here, -3. So I'm going to have y minus 48 equals, when I distribute, I'm going to get a -3x, and then -3 times -0 is just 0. Okay, last step, get y all by itself. So I plus 48 on both sides. Your 48s will cancel. So you just found the equation from 0 to 5 days. Y equals -3x plus 48. Ta-da. Okay, now the second piece, from 5 days to 10 days, same thing. Okay, if you think about the picture, it's just a flat line. The slope is 0. So watch what happens when we solve this. We have y minus, I'm just picking the very first point in the section, so 6, 33. So y minus 33 equals our slope m, which is 0, and then x minus 6. Well, if I distribute 0 on the right side, anything times 0 is just 0. So we are left with y minus 33 equals 0. Now get y by itself, add 33 to the other side, and so y equals 33. This happens every time you have a constant line, a line with a slope of 0. It will equal the number that it's at. So in this case, y equals 33. Okay, last one, section 3 or piece 3. Okay, we're going to plug into point and slope form. I'm going to use the very first, actually I'm going to use the second point so I don't have a decimal in there. I'm going to use 12, 30. So y minus y1, 30, equals my m, -150, parentheses x minus my x1, which was 12. So you can pick any point that's in the section. I chose the second point because it wasn't a decimal. Now distribute your -150. That's going to give us y minus 30 equals -150x. Okay, negative times a negative will become a positive. And 1.50 times 12 is 18. Okay, and then solve for y. So plus 30 on both sides. Now y should be all by itself. And so y equals -$1.50x plus 18 plus 30 is 48. So here is your equation for the third section. Okay, moving down. To write a piecewise function, you must write the equation and the domain for each piece of the function. So what you're going to do, remember that f of x is just like your y equals, and you're going to write each equation in this piecewise function, in this bracket. So we know that our first equation was -3x plus 48. Our second equation was just 33. And our last equation was $1.50x plus 48. You don't have to write y equals in there. You're just putting the equation. The f of x equals represents y equals for all three of those. Now, we put the equations in there. Now we have to put the domains. So after each equation, you should put a comma. Now, our domains, we actually already found up above. Okay, so if you look up here in red, these guys right here are our domains. First piece, second piece, and third piece. Okay, so again, first piece, second piece, and third piece. So if we go back down to the bottom, we can see that our first piece would be 0 less than or equal to x less than or equal to 5. Our second piece is 5 less than x less than or equal to 10. And our third piece is 10 less than x less than or equal to 32. The reason you just wrote the domains is because now you can tell which equation goes to which domain. So when you're talking about the 0 to 5 days, you know that you're looking at this equation. When you're going from 5 to 10 days, you're looking at this equation. From 10 to 32 days, you're looking at this equation. And that will tell you at any given day how much money you have left over from your prize winnings. So on part I, it says find f of 10 and explain what it means in terms of the problem situation. So we know we want to plug in 10 to the equation, but what equation are we going to use? There's 3. Okay, well, what you're going to do is look over on the side. Okay, you've got to decide which one 10 belongs. Does it go in this first? I don't think so. That's 0 and 5 days. Okay, look at the second. It says 5 to 10 days. Okay, this symbol right here means it's included. 10 is included in this second equation. 10 is not included in this third equation. That's why we use the less than symbol. We did not include it. So you are going to plug 10 into this second equation. Okay, so you plug your 10 into this equation, but is there anything to plug in? There's no variable. So that means on day 10, she still has $33. Okay, so right here, find f of 10. F of 10 equals 33. Now, if you plugged into either of the other equations, you'd literally have to put 10 in for x and then solve. But the equation we plugged into didn't have a variable, so it's just that answer. Think back to our graph. At day 10, did she have $33? Yes, she did. Okay, it says explain what it means in terms of the problem situation. On day 10, she has $33 left. Okay? All right. Okay, on the next page, example 3, it says write a piecewise function to represent the data shown. So what we're going to do is we're going to look at our table and we are going to find the patterns first of all. So I am looking now at the y values and I'm seeing that it goes 60, 55, 50, 45. I can see that it's going down by 5, but then it stops going down by 5. It continues with the 45s. So I want you to draw a line to separate. We can see that in this section right here, everything is going down by 5. Okay, now continue with your pattern. It goes 45, 45, 45, and then it changes. So we can see that in this section right here, there is no change. So just 0. And in your last section, it looks like it's going down by 2 every single time. So down by 2. You've just found the pattern in your f of x or y values. So now look over at your x values. In the first section, it looks like they're going up by 1. Second section, they're going up by 1. And the third section, they're going up by 1. So what we need to do is find the slope for each piece, because eventually we're going to write an equation for each piece. Okay, so off to the side, we're going to find the slope of each piece. Now the slope, I'm writing this at the top of the paper, is the rise over the run. Okay, your rise is your y values, so I wrote it above the table. Your run is the x values. So that means in our first piece, our slope, or m, in the first piece, our rise, well, it was going down 5 every time. So negative 5 over our run, well, that was 1. Okay, the second piece, our rise was 0, our run was 1. And the third piece, our rise was negative 2, and our run was 1. So you have just found the slope for each of those pieces. Remember, our second step is to plug into point slope formula. So if we plug into point slope formula, okay, I'm coming over on the right side, I'm going to do the first section. I'm also going to pick the very first point to plug into point slope formula. So when I plug in, it's going to say y, whoops, let me use the pen, not the highlighter. It's going to say y minus 60, that's my y1, equals my slope, which we found was negative 5 over 1. And negative 5 over 1 is just negative 5. And then x minus x1, which is 0. Okay, distribute your negative 5, and you'll get y minus 60 equals negative 5x. Negative 5 times negative 0 is just 0. Now, mental math, add your 60 over to the other side. So if I add my 60 over to the other side, y is going to equal negative 5x plus 60. This is the equation for the first piece. Now, your second piece. Your second piece is really easy in this case because the slope is 0. That means it will look like a flat line. When your slope is 0, your answer for your equation is just y equals that number. So in this case, because it stays 45 every time, it's just y equals 45. And your third one, I'm going to use the first point when I plug in. And so y minus 43 equals our slope, which was negative 2, parentheses x minus 7. Okay, distribute your negative 2. Y minus 43 equals negative 2x plus 14. Add 43 on both sides. And 14 plus 43 is 57. So y equals negative 2x plus 57. So you have just come up with your equation for all three pieces. So we're almost done. All we have to do now is write it as a piecewise. So what you're going to do, I'm zooming in a little bit. Okay, when you write your piecewise function, you're going to say f of x equals, we use f of x because it's a function, and then you're going to draw the fun little bracket. you need to list all three of your equations. So we had negative 5x plus 60 as our first equation, 45 as our second equation, and negative 2x plus 57 as our third equation. So remember, functions have their equations and their domains. We just did the domain or the functions, so you should put commas after the equations, and now we're doing the domains. Now, your first piece is going to come from, okay, so if you look up here, your first equation comes from this box right here. It starts at 0 and it ends at 3. So that means your domain for the first section is 0 to 3. So what you're going to do is say 0 to 3. You put your x in the middle. Now we can see that 0 is included in this section and 3 is included in this section. So that means when we put our symbols, we have to have the equal to sign, less than or equal to. Now, because that domain ended in 3, our next domain has to start with 3. So we started with 3, and our second section ends with 6. So it's going from 3 to 6. Put your x in the middle. And 3, you should notice, is not included in this second section. So we do not use less than or equal to, we just use less than. But our 6 is included. And the last piece, we have to start out with 6. And it goes until 9. Okay, the 6 is not included in the third section. So we have to use the less than symbol, and 9 is included, so we use the greater than symbol. This right here is your answer. That is your function. Now, example 4. Graph the following linear piecewise function f of x below. Then complete the function notation problems. Hint: the domain to the right of each piece tells you for what x values the equation is used for. The domain also specifies if it's opened or closed dots should be used at the end of each piece. So looking at this function, we know we're going to graph it. You've got a piece that x's are less than 2, and you have a piece where x's are greater than 2. I think it's helpful to draw a line at 2 so that you can remember the difference between the two equations. So I drew a line at 2. That's just to help me. Then you're going to start graphing each piece. So our very first equation says negative 2x plus 1. So when I graph this, I'm going to start with a point at positive 1. And I'm going to go down 2 over 1. 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 Now, all of those points are creating a line, but I'm only going to draw that line again where the x values are less than or equal to 2. Well, less than 2 would be on this side of the line. So you should only draw your line on this side of x equals 2. Okay, these other points that you drew can be erased. Now, for the second equation, you should start at negative 4. We have to use an open circle this time because it is less than 2, and that is an open circle. So we start down at negative 4. Okay, and we're going to put a point. 1, 2, 3, 4. And we're going up 5. 1, 2, 3, 4, 5 over 1. up 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, over 1. Okay, up 1, 2, 3, 4, 5, over 1. But remember that you have to have an open circle. So you're only going to draw this on the right side because you have to be greater than 2. But when you draw your line, you have to have an open circle when you start. So this should be an open circle. And then you should have your line. Okay, obviously your line should be better than mine. Okay, so what you're going to do on part A, it says f of 3. You're going to plug 3 into the equation, but you've got to decide which equation to plug 3 into. Well, 3, is it less than or equal to 2? Or is it greater than 2? I believe it's greater than 2, so we're going to plug into the bottom equation. So it would say 5, plug in a 3, minus 4. Well, do mental math. 5 times 3 is 15. If you take away 4, you get 11. So the answer is 11. Okay, part B. It says f of 2, so you're going to plug in a 2. Well, which one includes 2? The first one or the second one? Okay, the first one says x less than or equal to. So this top one is the one you're going to plug into. It includes 2. So when I plug into the top equation, it says negative 2, plug in 2, plus 1. Well, mental math, negative 2 times 2 is negative 4. And if I add one more, I get negative 3. Okay, go look at your graph. See if these are looking like they should. If you go to 2, okay, on the x-axis, here's 2. You should be down at negative 3. Well, look, 1, 2, 3. Oh, ta-da. Okay, if I come over here, go to 3, I should be up at 11. 1, 2, 3. Okay, this should be way up here at 11, which it looks like it is. Now, if I plug in f of negative 4 right here, negative 4 is less than or equal to 2, so I should be plugging into the top equation. So negative 2, plug in a negative 4, and then add 1. Okay, mental math. Negative 2 times negative 4 is positive 8, plus 1 more is 9. So if we go to negative 4 on the graph, 1, 2, 3, 4, this should be up at 9. Again, my picture wasn't very good, so hopefully it would be up there. Okay, f of negative 2. Negative 2 would be plugging into the top equation. So we have negative 2, plug in negative 2, plus 1. Negative 2 times negative 2 is 4, plus 1 more is 5. Now, the last one's a little bit different. It says, for what x value is f of x equal to 5? That wants to know when y equals 5, what is the x value? So, on your picture, go to y equals 5. 1, 2, 3, 4, 5. And you should see what the graph looks like. Well, if I go to the right, there's nothing there. But to the left, your picture should be a lot better than mine. You will see that it is at negative 2. So the answer is x equals negative 2.